Hello everyone, my name is Shyam Chauhan and today we are going to cover topic number 1.3 and theorem 1.2. Topic number 1.3, revisiting irrational numbers. Irrational numbers are those numbers which is of the form under root p where p is a prime number. That means irrational number equals to under root prime number. For example, under root 2, under root 3, under root 5, under root 7, and so on. Now let us see theorem 1.2 with one small example. Theorem 1.2, p is a prime number, then we have a and a square which is a positive integer. So let's take p equals to 2, a equals to 12 and a square equals to 12 square, that is equals to 144. Now for a equals to 12, prime factorization of a, that is equals to 2 into 2 into 3, which is equals to 2 square into 3, and I can write prime factors of a equals to 2 comma 3. Now for a square, prime factorization of a square, that is equals to 2 raised to 4 into 3 square, and prime factors of a square, that is equals to 2 comma 3. So let us understand this theorem. That is, we have written a equals to p1 into p2 into p3 up to pn, that is prime factorization of a, that is equals to 2 into 2 into 3, where p1 equals to 2, p2 equals to 2 and p3 equals to 3. So I can write p1 equals to 2, p2 equals to 2 and p3 equals to 3. Now further in this theorem, where p1, p2 up to pn are prime, that is p1, p2 and p3 are prime numbers and not necessarily distinct, that is p1 and p2 are not distinct. Theorem says that a square equals to p1 into p2 into up to pn whole square, that is equals to prime factorization of a square, that is equals to 2 square into 3 into 2 square into 3, that is equals to 2 raised to power 4 into 3 square, which can be written as prime factorization of a into prime factorization of a, that is equals to p1 square into p2 square up to pn square. Now we are given that p divides a square, that is p equals to 2, which divides a square is given, that is 2 divides 12 square is given. P divides a square is given, Therefore, from the fundamental theorem of arithmetic, it follows that p, that is equals to 2, is one of the prime factor of a square. We have prime factors of a square, that is equals to 2 and 3, and p equals to 2, which is one of the prime factor of a square. However, using uniqueness part of fundamental theorem of arithmetic, we realize that only prime factor of a square are p1, p2 and up to pn. That is, prime factors of a square, which is 2, 3, that is p1, p2, and not p1 square and p2 square. And so p is one of the p1, p2 up to pn, that is p is one of the prime factor of a square. Since we have a equals to p1 into p2, so p is also the prime factor of a, that is p is also prime factor of a, and hence p divides a. P is prime factor of a, hence we can write 2 also divides 12. Now let us write this theorem. Theorem 1.2. We are given with p, which is a prime number, then we are given with a, which is a positive integer, and a can be written in product of primes, or we can say the prime factorization, that is equals to p1 into p2 into p3 up to pn, where p1, p2, p3 up to pn are prime numbers. Then we are given with a statement, that is p divides a square, which is given, and we have to prove that p divides a. So let us start the proof, that is we are given that p divides a square, so p is one of the prime factor of a square. But from the fundamental theorem of arithmetic, we can write prime factors of a square are p1, p2 up to pn, which is also the prime factor of which are also prime factor of A. Therefore, P is also the prime factor of A. And hence P divides A. In next lecture, we will cover theorem 1.3. Thank you.